Logs are the most robust and context rich parts of your application. But why? And what does that mean for you? Hi, everyone, and welcome to the Elastic YouTube channel. My name is Sophia, and I am a developer advocate here at Elastic with an absolute love for all things observability. Let's get into it. But before we talk about logs, let's talk about observability and how you begin to get insight into any of your applications. Observability is the ability to have visibility into your distributed systems, applications, services, all of the above, anything. I mean, you name it. When we speak on observability, there are usually three primary pillars that we like to focus on: logs, traces, and metrics. Other pillars often mentioned when it comes to observability include profiling and events, but we'll get to those in a subsequent video. Logs can be defined a million ways, but at their core, logs are textual, timestamped records that give you detailed information about the state of your system. Logs answer the who, what, when, where, and why of your application. Interestingly enough, logging is technically one of the oldest forms of monitoring applications, basically growing hand in hand with software debugging. Side note, OpenTelemetry is a framework and toolkit created by the Cloud Native Computing Foundation. It's actually the current industry standard, and it helps facilitate the management of telemetry data. Since it's tool agnostic and vendor neutral, it's universal and can connect to any observability backend. Another fun fact, Elastic is actually one of the largest contributors to OpenTelemetry. Now that we've gone over the basics of logging and observability, I would love to tell you more about the different kinds of logs that there are. There are container and cloud logs from Kubernetes and AWS Cloud. There are network logs that can track firewall interactions and traffic flow. There are application logs from your apps, such as user activity and any errors that it might run into. And honestly, so many more types of logs, including custom logs. Although there are many different types of logs, logs usually come in three forms: unstructured, structured, and semi-structured. Unstructured logs in plain text can be great for developers wanting to add observability quickly while developing. And unstructured logs are very common in legacy systems before universal telemetry standards. Unstructured logs are actually the most commonly logged logs by applications. The drawback about unstructured logs is that they're usually made for human readability and they can be hard for machines to parse. When it comes to using Elastic as your observability backend, unstructured logs can be handled just as efficiently as structured logs. So, after talking about unstructured logs, I'd love to talk to you about structured logs, basically the exact opposite of unstructured logs. Structured logs, like common event format CEF and common log format CLF, are great for teams because machines can parse them very easily within their defined schemas. They can provide clarity and context across complex distributed systems. However, they are not as flexible and readable to humans as unstructured logs. Lastly, you'll find there's a middle ground: semi structured logs. Think JSON, XML, W3C. These type of logs usually have the best of both worlds. They have the human readability and rapid implementation that unstructured logs have, as well as the machine parsability and context that structured logs tend to have. But that's not the whole story. Semi structured logs also run into some issues, such as data quality and consistency issues, usually caused by naming the same field differently across applications. Semantic conventions, especially those curated by OpenTelemetry, have helped alleviate this problem by providing a standardized set of rules for naming and structuring telemetry data so that across all industries, telemetry data is consistent. So now that we know about all different types of logs and different forms of logs, what does using Elastic for logging mean to you? During ingestion into Elasticsearch, all your logs, structured, unstructured, or semi structured, can be converted to fit ECS, or the Elastic Common Schema. ECS enables all of your logs to talk efficiently with each other within the Elastic ecosystem to avoid any conflicts. When using any of the 470 plus Elastic Agent integrations, you can automatically have ECS applied to your data. These ECS formatted logs can even pair with elastic distributions of OpenTelemetry, an ecosystem of distribution tools, including an OTel collector and several language SDKs that allow you to tailor your data to Elastic with full production support. If you have custom events that cannot be mapped to ECS, don't panic. You can add them to your events using custom field names within Elastic. Now that you know several ways that any of your logs can be ingested into the Elastic Stack, I want to go over some of the benefits of using Elastic for handling your log telemetry data. Using Elastic for logging means that you have the benefit of full text search, something Elastic has been excelling at since 2010 when we were a baby open source project. Elastic makes giga, mega, tera, and petabytes of data readily searchable through several robust AI tools. As mentioned before, although most industries are moving towards using more semi structured and structured logs, unstructured logs are the most common type of log, especially within legacy systems or even the initial development of new systems. I mean, this is how I first learned to debug with a simple printf statement. While easy for humans to understand, machines are quite different from humans, and they thrive on structured logs, which is when Elastic's newest feature, Streams, comes into play. Streams is the newest feature of the Elastic Observability Suite, and it's so cool. It's available right out of the box with serverless instances and with any Elastic versions above 9.2. There are several problems with unstructured logs that Streams solves. One is the massive volume and unstructured nature of these logs that can make them difficult to use effectively. With unstructured logs, teams are either forced to build complex data pipelines that can take forever to build, or they're forced to drop valuable log data in order to control costs. But there are several things that Streams does in order to control these problems. So, what does Streams actually do? Well, first of all, Streams lets you log everything effortlessly. Send all of your logs, unstructured or structured, into your Elastic Stack. Then Streams, powered by LLMs, will extract your data from logs. One of the coolest things about Streams is the AI assistant, which can turn hours of work into immediate answers. You can use it to analyze any logs that have been ingested through your one endpoint, or you can use it to create ESQL tools in order to better query your data. Significant events can automatically be flagged by Elastic's AI, or you can mark them yourself. Significant events automatically surface critical anomalies and patterns, such as out of memory errors, internal server failures, server crashes, shutdown and startup events, anything you can think of. Lastly, Streams allows for AI data query optimization using the Elasticsearch Query Language, or ESQL, our own piped query language that allows you to efficiently query any indices you have within your Elastic Stack. You can get started with any of these tools or Streams with an Elastic Serverless instance that you can have a 7-day free trial with. Well, thank you so much for joining. I hope that you learned a little bit more about logs today. And if you knew everything, I hope you had a good time watching. But I will see you in the next video. And once again, thank you so much for watching. Have an elastic day.